Local dark holes, more commonly known as black holes, are some of the most fascinating and enigmatic phenomena in the universe. These cosmic giants have enormous power, but they are almost completely invisible to us. Imagine a black hole 2 to 4 million times the mass of our Sun. Thanks to extensive research over the last few decades, we have gone from knowing almost nothing about black holes to revealing more and more details about them, allowing us to study these mysterious entities more closely. Physicist Michio Kaku recently announced a groundbreaking discovery. We finally got a glimpse inside a black hole. This new knowledge illuminates aspects of the universe that the scientific community may have initially ignored. Join us as we delve into black holes and discover what lies within these cosmic behemoths. The story of black holes begins with Albert Einstein. In 1916, Einstein published his general theory of relativity, which predicted the existence of black holes. At the time, the concept of black holes was purely theoretical. It took another 50 years before the scientific community found evidence for the existence of black holes. That pivotal moment came in the 1960s, when astronomers studying the Cygnus constellation discovered a strange light blue star emitting X-rays. This star was not stationary, but an orbiting massive dark object. Further research showed that the X-rays did not simply drift into space, but were absorbed into this dark entity, hence the name black hole. This discovery was monumental because it confirmed that black holes were not just a figment of Einstein's imagination. The black hole discovered in the Cygnus constellation was called Cygnus X-1. About 6,000 light-years from Earth, Cygnus X-1 is a cosmic giant many times brighter than the Sun and incredibly dense. Its attraction is so strong that even light cannot escape it, earning it the nickname black hole. The confirmation of the existence of Cygnus X-1 was a watershed moment in astrophysics, prompting scientists around the world to dive deeper into the study of black holes. They soon discovered that Cygnus X-1 was only the beginning. After the discovery of Cygnus X-1, scientists started looking for more black holes. Their findings were astonishing. The Milky Way alone may have more than 100 million black holes. But due to their elusive nature, we still lack an exact count. However, the fact that there may be millions of black holes in our galaxy underscores the importance of studying them. The main problem with black holes is their gravity. The gravitational force of a black hole is so extreme that anything entering it is compressed to an astronomical extent, making it a singularity. Simply put, black holes act like cosmic vacuum cleaners, sucking up everything around them. One of the scariest aspects of black hole research is the notion that when one collapses into one, it is stretched into a single line before finally collapsing, a process known as spaghetti formation. Although the nearest black hole to Earth is approximately 1,500 light-years away, it is still close enough to raise questions and concerns. In 2021, scientists achieved a major milestone by capturing the first clear image of a black hole, specifically black hole M87. This black hole was imaged over several nights, and the individual images were combined into a complete picture. This composite image showed that black holes have 3 layers: the event horizon, the photon ball, and the singularity. The first floor of a black hole is the event horizon, the point of no return. If an object crosses this limit, it will inevitably be pulled into the black hole. The second layer, the photonosphere, is the region where light orbits the black hole. Any light entering this region is captured by the black hole's gravity. Finally, there is a singularity at the core of a black hole, where matter is compressed into an infinitesimally small point and the known laws of physics cease to apply. Each black hole is unique, although they generally follow the same 3-layer structure. However, their mode of operation can differ significantly. Unlike other celestial bodies, we cannot directly study black holes. Scientists rely on indirect observations, such as radiation emitted by the gas and dust surrounding black holes. Sending probes into black holes is impossible because everything that reaches the event horizon is pulled towards the singularity and pushed into nothingness point. One of the most compelling theories about the origin of black holes is that they are created by the collapse of massive stars. When a star runs out of fuel, it can no longer produce enough energy to resist the inward pull of gravity. If a star is massive enough, it will continue to collapse until it becomes a singularity. To understand the nature of black holes, NASA scientists turned their attention to the center of the galaxy M87. They detected a powerful vortex of superheated hydrogen gas spinning at an incredible speed of 1.2 million miles per hour. The sheer force of that spinning gas should have torn it apart, but didn't. The researchers concluded that it was blocked by a titanic mass at the galactic core, probably a supermassive black hole weighing 2 to 3 billion suns. In 1963, New Zealand mathematician Roy Kerr used Einstein's gravitational equations to give the best description of a rotating black hole to date. Kerr showed that a spinning black hole does not collapse into a point, but into a fiery ring or thin disk. This spinning disk, known as the ergosphere, is where the laws of physics begin to break down. Kerr's solution also predicted the existence of an Einstein-Rosen bridge, or wormhole, a hypothetical tunnel through space that connects two separate regions of the universe, or even a parallel universe. The 2019 effort to photograph a black hole was a historic achievement. The Event Horizon Telescope captured images of the black hole in the galaxy M87. That image provided visual confirmation of black holes, revealing the shadow of the black hole against the glowing gas swirling around it. This pioneering photo confirmed Einstein's theories and opened up new possibilities for a deeper study of black holes. Despite their mysterious nature, black holes play a crucial role in forming galaxies and the entire universe. They influence the movement of stars and gas around them and the formation and evolution of galaxies on the cosmic timescale. Recent advances in technology, such as the development of gravitational wave detectors such as LIGO and Virgo, have opened up new possibilities for studying black holes. Gravitational waves, waves caused by the motion of massive objects such as black holes, offer a unique way to observe these elusive cosmic phenomena. Future missions and observatories such as the James Webb Space Telescope and the Event Horizon Telescope promise to deepen our understanding of black holes. These instruments allow astronomers to study black holes with different wavelengths of light and take more detailed pictures of their surroundings. By studying the extreme physics near black holes and observing their interactions with their surroundings, scientists hope to gain insight into the fundamental nature of space-time and gravity.